projects. In this video, we are going to explain about the project title All-in-One Emotion, Sentiment and Intensity Prediction using a multitask ensemble framework. Introduction. The project's first goal is to build a single efficient system capable of understanding and predicting emotions, sentiments, and how intense they are, all from the words people use in text. The project plans to improve the accuracy and depth of understanding emotions and sentiments by using a combination of models and techniques. This ensemble approach combines various methods, making the analysis more reliable and detailed. The project acknowledges that understanding emotions from text is challenging due to the complexity of words, their different meanings in different contexts, and the varying levels of intensity with which people express their feelings through words. This awareness emphasizes the need for a thoughtful and subtle approach to prediction. Objective: predicting emotions and sentiments in text is highly challenging due to the subtle and complexities of human language. Words can carry subtle meanings and emotions, heavily influenced by context, culture, and personal experiences. The same word or phrase can convey different emotions based on the situation. Additionally, understanding the varying levels of intensity with which these emotions are expressed adds another layer of complexity. Successfully predicting emotions and sentiments necessitates navigating these intricacies. To address the challenge outlined, the project advocates for a sophisticated and comprehensive approach. This approach involves amalgamating diverse models and strategies to collectively contribute to a more accurate prediction. By integrating different models like GRU, RNN, CNN, and combining their insights through an ensemble framework, the project harnesses the strength of each model. This collaborative effort optimally exploits the unique abilities, resulting in a more robust and precise prediction mechanism. The project brings innovation by proposing a novel method for emotion and sentiment prediction. By utilizing a blend of advanced models such as GRU, RNN, and CNN, the project demonstrates creativity and intelligence in approaching the prediction challenge. Requirements. The requirement of the project are hardware requirements, in which we have operating system of Windows, processor of Wi-Fi and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. Essential libraries and packages are imported. These libraries contain pre-built functions and tools that facilitate data manipulation, model creation, training, and evaluation. Common libraries include TensorFlow or PyTorch for deep learning, Pandas for data handling, and Scikit-learn for various machine learning tasks. Exploring the dataset. This step involves a thorough examination of the dataset that will be used for training and testing the models. It includes understanding the structure of the data, its features, distribution, and other relevant information. Exploratory data analysis (EDA) is performed here to gain insights that help inform pre-processing and model building decisions. Data processing. In this step, the raw dataset is prepared for use in training models. Tasks such as tokenization, breaking text into smaller units like words or characters, handling missing data, removing noise, and converting text into numerical representations, vectorization are performed. This processed data is what the models will be trained on. Splitting the data into train and test. The dataset is divided into two subsets, a training set and a testing set. The training set is used to train the models, while the testing set is kept separate and is used to evaluate the model's performance. This separation helps ensure the model's ability to generalize to unseen data. Building the model. The project utilizes various models including GRU, RNN, CNN, and a hybrid model. Each of these models is a different type of neural network with unique architectures and capabilities for processing and understanding text data. GRU, Gated Recurrent Unit. GRU is a type of recurrent neural network, RNN, that is particularly effective for processing sequential data like text. It has a gating mechanism that helps it capture long-term dependencies in the data. GRU can retain relevant information from the past, making it suitable for understanding the context and emotional flow within text data. RNN, Recurrent Neural Network. RNN is a type of neural network designed to handle sequential data by maintaining a hidden state that carries information from one step to the next. This is crucial for understanding text as it allows the model to consider the sequence of words and the context they provide. However, traditional RNN can struggle with capturing long-term dependencies, which is where models like GRU address this limitation. CNN, Convolutional Neural Network. CNN are widely known for image processing, but they can be adapted for text analysis as well, especially for tasks like sentiment analysis. In text analysis, 1D convolutions can be applied to capture local patterns or features in the text. By using multiple convolutional filters, CNN can identify different features in the text, aiding in understanding sentiments and emotions expressed in the input. Hybrid model. The hybrid model is a fusion of different architectures, such as combining RNN and CNN. It leverages the strengths of both models for a more comprehensive analysis of text. For instance, RNN captures sequential dependencies while CNN captures local patterns effectively. Combining them can result in a model that understands the broader context as well as the specific features in the text, leading to improved prediction for emotions, sentiments, and intensity levels. Training the model with train and test. Once the models are constructed, they are trained using the training dataset. Training involves adjusting the model's parameters using optimization algorithms, minimizing prediction errors, and fine-tuning the model's ability to accurately predict emotions, sentiments, and intensity levels. The testing dataset is used to evaluate how well the model performs on unseen data. Flash framework with SQLite for sign-up and sign-in. In this module, the Flash web application framework is utilized to create an interface for user sign-up and sign-in. Flash provides a platform to develop the backend of the application, managing user authentication processes and interacting with SQLite database. User gives input. User input text, which is a crucial step in this project. Text input could be in the form of sentences, phrases, or paragraphs. This input serves as the basis for the emotion, sentiment, and intensity predictions that the system will generate. The given input is pre-processed for prediction. The given user input needs to be pre-processed before feeding it into the trained model for prediction. Pre-processing involves steps like tokenization, stop word removal, stemming or lemmatization, and converting the text into a format suitable for the model, such as numerical vectors. This step ensures that the input is appropriately transformed and ready for prediction. Trained model is used for prediction. In this module, the pre-processed user input is fed into the trained model. This model is designed to predict emotions, sentiment, and intensity based on the given input. The trained model leverages a multitask ensemble framework, which means it's capable of handling multiple related tasks simultaneously. In this case, predicting emotions, sentiment, and intensity. Final outcome is displayed through front end. The predictions made by the model encompassing emotions, sentiment, and intensity are the final outcomes of the system. These outcomes are displayed to the user through the front end of the application, providing a user-friendly interface for the user to view the predictions and analyze the emotional and sentiment context of the given input. The front end includes visualizations or structured display of the predictions to enhance user understanding and experience. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now hit enter. After running the app.py file, the Flash framework will host the application locally at the default address, which is this, and port, which is this. Now copy the local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flash framework. Now click on sign up button. If we are a new user, we need to register first. But I have already registered, so click on sign in button. Enter the username and the password which we have created. I'm entering the username and the password and click on login. The homepage of the project is displayed. So this is the text box. Here we need to enter the message, and after entering the message we will predict the sentiment of the message. So I'm entering the message. This is the message which I have entered. Now click on predict. So we can see we got the result for the content. The sentiment of the content is sadness. Now let us enter one more message and check the sentiment of that message. So I'm entering one more message. This is the message which I have entered. Now click on predict. So here we can see the sentiment of the content is anger. Now let us enter some more messages. I'm entering one more message. This is the message which I have entered. Now click on predict. So here we can see we got the result for the content. The sentiment of content is love. Now let us enter some more messages. I'm entering one more message. This is the message which I have entered. Now click on predict. So here we can see we got the sentiment of content is surprise. So in this way, by entering the message, we can predict the sentiment of the content, whether it is surprise, love, anger, fear, etc. The conclusion of the project is the project adopts a holistic approach to comprehend emotions, sentiments, and the intensity levels in textual data. By integrating multiple models and advanced techniques, it aims to cover a broad spectrum of expressions and linguistic subtle present in human language. This comprehensive approach ensures a more thorough and accurate understanding of how people convey their feelings and opinions through text. Through the integration of an ensemble of models, the project significantly enhances the accuracy of predicting emotions and sentiments. Each model within the ensemble contributes its unique strengths and capabilities, collectively refining the prediction process. This results in a more precise understanding of how language is used to express emotions and sentiments, thus elevating the accuracy and reliability of the prediction system. The success of the project opens door to a multitude of practical applications. It can be used to analyze customer feedback, track sentiments on social media platforms, and even assess mental health based on the language individuals use. These applications are crucial in various domains, providing valuable insights into public opinion, consumer satisfaction, and mental well-being. Additionally, the project sets the stage for future improvements, aiming to further refine prediction capabilities and unlock even better performance and accuracy in these domains.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.